So we have 4 more lectures left. We're going to start with this lecture on the natural functions, and then we'll end with the trigonometric functions. I'm going to break this into 2 parts. So we have today natural functions part 1, and then next week we'll talk about part 2. So in 1, I just want to introduce the basic ideas. So what are the natural functions? Well, in the last section we talked about power functions mostly. So hopefully you know that power functions look like this: x to some power. So you could have x squared, or x to the 1/2, which is the square root of x, or you could have x to the, let's say, -2, which is 1 over x squared. And we can add, subtract, multiply, divide, and compose these functions to make new functions. The next type of functions we're going to talk about are called natural functions. And so what are the natural functions? There's 2 types. So f of x equal to e to the x, where e is this number 2.718 ... When I think of e, I also think of pi. So pi is equal to 3.14 blah blah blah. These are called transcendental numbers. When I think of pi, I think of circles. And when you think of e, you probably don't know this, but e has to do with continuity, really. So this number e pops out in a natural way if you try to understand how things are changing at some instant. And so our first, the natural function, so the natural exponential function, is given by f of x equal to e to the x. There's also the natural logarithmic function. So the natural logarithmic function and instead of calling it f, we'll just call it g of x. So g of x, and we write this as ln of x, which stands for the natural logarithmic function. The way these things are related is that they're inverses of each other. So if you have a domain here, and say you have a point, let's say 2, and you apply the function e to the x to it, it's going to take you over here to e squared. And then the inverse function, ln of x, will take e squared back to 2. So you can actually see here that ln of e squared will be equal to 2. And you can check this on your calculator. So what's nice about this course is you're allowed to use a graphing calculator, so you can kind of check things with it. So if you do ln, so there's the ln button, of second e to the, and then you put a 2 here, you'll see you get back exactly 2, because these are inverses of each other. So remember the idea of an inverse. One function goes one way, the inverse goes back. So we could call this, if you want, f of x equal to that, and we could call this f inverse of x. Now there are lots of different types of exponential functions. So any number to x is considered an exponential function. So like 2 to the x, or 3 to the x, or even 1/2 to the x. And you have lots of different logarithms, like log base 10 of x. So if you don't write a number in the base here, it means log base 10. So this is equal to log base 10 of x. This is one you might be familiar with. You can certainly do log base 2 of x. The important thing to realize here is that you really do not need to understand these types of exponential functions, or even these types of logarithmic functions, as long as you understand e to the x and ln of x. The way this works is we're going to see that e to the ln of the anything, let's just put any, is actually equal to the any, and ln of e to the anything is actually equal to the anything. And so these 2 identities right here will allow us to work with most of these types of functions. So suppose I want to work with, let's say 2 to the x. If I want to understand everything possible about 2 to the x, I can write this as e to the ln of 2 to the x. And then we're going to see a property of logarithms, which you've probably seen before, will allow us to take this x and write it down in front. And so here we're going to write this as ex to the ln of 2. And these are sort of the two sayings that I'll have you guys sort of memorize. E to the ln of the anything is the anything, and ln of e to the anything is the anything. And they'll help us later on. To do logs in different bases, like suppose you want to figure out what log base 2 of x. You want to study this logarithmic function. Well, you can write this as ln of x over ln of 2. We'll see that there's another formula, log base b of x is equal to, this is an identity, ln of x divided by ln of b. Okay, so we looked at the two formulas here, e to the x and ln of x. We haven't talked about the graphs, so let's talk about the graph of e to the x. All right, so the graph of e to the x looks just like this. It has a horizontal asymptote at y equals 0, and it grows really fast. So this is the function, e to the x. And then ln of x is the inverse. So it has, instead of a horizontal asymptote, it has a vertical asymptote at x equals 0, and it looks like that. So these are two graphs. And if you want, we can call this, well, let's call it g of x, since I was calling it g of x before. So g of x equal to ln of x. And so here are the graphs that you should be familiar with. Above here were the formulas. And then we're going to talk about the rules that you've seen before and kind of review them. And so for the rules, let's take a look here. So this is the handout I gave you in class. So when you multiply the natural exponential function, you add exponents. So suppose you have e squared times e cubed. This is the same as e to the 5th, 2 plus 3. Anything to the 0 power is equal to 1. When you divide the natural exponential functions, you subtract exponents. So, if you have e to the, let's say, 3 divided by e squared, this would just equal e to the 1. So usually we don't write the 1. As usual, a negative exponent means put it in the bottom. When you raise an exponential to a power, you multiply. So if you had e squared quantity cubed, this would actually be e to the 6. And here we're going from power form to radical form. So m is the root, it's the bad thing, and n is the power. So if you have e to the, well, let's say 2/3, this is equal to the cube root of e squared. So that's how we work with these natural exponentials. And of course, instead of using e, which is 2.718, blah, 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 on and on, you could use any number for e. These rules still work if you replace e with 2 or 3 or 4, but we're going to work solely with the natural exponential number. All right, for logarithmic functions, a couple things. This is really important. This is how you define a logarithm. And so this is what it means. Otherwise, it's sort of gibberish. What's the natural log? Well, it's defined to be this. So if you have something, let's suppose you have, I don't know, let's say, different. Let's use a different color. Suppose I have ln of x equal to 3. And I want to figure out what x is. Well, do what it says. There's a little e here we just don't write. And it says e to the y is equal to x. So that's what it says. So I know there's a little e here. And so this implies that e cubed is equal to x. So e cubed is equal to x. This is important when you start talking about on your calculator what you're actually computing. Like suppose you take the ln of 3 and you get back this number. So ln of 3 is equal to this number 1.0986 blah blah blah. What is this number really? Well, if you think about it, there's an e here. So this number, if you raise e to it, you should get back 3. And on your calculator, you can check this. So if you take second ln, put the e to the function, and you put in the last answer, you'll get back 3. So this is something that's worth sort of writing down and thinking about. When you add logarithms, you multiply inside. When you subtract, you divide. So easy examples of these, like if you have ln of x squared and you take away ln of, let's say, x, this is really ln of x squared divided by x. So x is canceled, and this is just equal to ln of x. So we're going to do some simplifications when you add logarithms versus when you subtract, you divide. This one's very important. If you have ln of something to a power, the power can come down in front. And so this helps us solve exponential equations. So like if you have like e to the x equal to 3, and you want to solve this for x, so what number of x do you plug in here? When you take e to it, do you get out 3? What you're going to do, and we'll do one of these in a little bit, you're going to ln both sides, and then you can use this property which says that'll bring down this x. So functions really are like tools sometimes, and they can help us solve certain problems. So we have x ln of e equal to ln of 3, and ln of e, you can see, is a nice number of 1. ln of e is always equal to 1, and so you just get x equal to ln of 3. And you can test your answer, because if you take e raised to it, you better get out 3. So on my calculator, I can take second e to the ln of 3, and I'll get out 3. And so it checks. Ln of 1 is equal to 0. This is true for any logarithmic function. And these are also true for any logarithmic function. We're just going to use the natural logarithm throughout this class. These are very important, right? They'll help us later solve various problems. Ln of e to the anything is the anything, and e to the ln of the anything is the anything. This works because they're inverses of each other. So think about this. I think it's worthwhile. If you plug anything in here, and you take e to it, so you take e to the x, you plug in the anything, you get e to the anything, and then if you plug that into ln of x, it's going to take you right back because they're inverses of each other. And the opposite works too, okay? So if you have e to the ln of anything, you get the anything, and also if you have ln of e to the anything, you get the anything. You can go either way. You can go this way and then back that way, or you can go back that way and back this way. And the reason why these are so useful is because if you have any base, okay, any number, so here I have b to the x, so let's say you have 3 to the x, I can rewrite this in terms of the natural exponential as e to the ln of 3 to the x, because e to the ln of the anything is the anything, and I know that's e to the x ln of 3. So if I know how the natural exponential function works, then I know how 3 to the x works. Same thing over here. If I have log base 3 of x, then I can work with it by using the identity it's ln of x over ln of 3. So suppose you want to find log base 3 of 5. I simply would do ln of 5 divided by ln of 3. And I can plug that into my calculator. So ln of 5 divided by ln of 3. And I get out this number, 1.464973521. Goes on, probably forever and ever. And what does this number represent? Well, if you take 3 and raise it to it, you better get back 5. So let's check it out. So 3 raised to that answer, and you get back 5, because that's by definition. Right? Remember, what does the log say? It says this raised to that equals that. So very important. And so those are the rules for logarithms. So you have them for your notes. The next thing we want to do is we want to solve some equations. So try to get used to working with exponential equations and logarithmic equations. So let's take a look at this first one right here. And so what do we have? We have what? We have 3 e to the 2x minus 1 equals 9. And I want to solve this for 2x. So the first step is I can get rid of that 3 by dividing both sides since I'm multiplying. Remember, to solve an equation, you simply do the opposite, the inverse. So since I'm multiplying, I'll divide. And so I get e to the 2x minus 1 equals 9. And then the problem I have now is that my x is in the exponent. But that's no big deal because I can take out my ln function and ln both sides, and I know a property of ln's. This will come down, right? So if you have ln of x to the y, you know that's equal to y ln of x. And so I'm going to get 2x minus 1 So this quantity times ln of e equal to ln of 9. And I know from my rule sheet there, ln of e is 1, so I can drop it off. And I have 2x minus 1 equal to ln of 9. I'll add 1 to both sides. So 2x equals ln of 9 plus 1. Now be careful here. A lot of times what students like to do is they try to combine the 9 and the 1. This ln, this 9, is inside the ln function. So I say, ln's like a car and 9's its passenger, and you can't get out unless you can't get out or put another passenger in unless you use another one of those rules that we have, and we don't have one. So it's ln of 9 plus 1, and so x is equal to ln of 9 plus 1. And you divide both sides by 2. And so that's my answer for x. Now I can check my answer by plugging this into my calculator. So left parenthesis ln of 9, in parenthesis plus 1, in parenthesis divided by 2. So that's my x. And if I plug this in, 3e to the 2x minus 1, so I have 3 second ln 2 times this second answer, and then minus 1, in parenthesis. I better get out, oops, I must have missed something. Right? Did I miss something here? So I got out 27. And what should I get out? I should get out 9. So let's go back and see where my mistake occurs here. So let's go back up to this first part. Make sure I copied down the question right. Divide both sides by 3. And here's where I made my mistake. 9 divided by 3 isn't 9. What's 9 divided by 3? And you say, oh, that's supposed to be 3. Right? So always check your work because it's really easy to make mistakes. So this should be ln of 3. So come back here. Let's check it again. So I can hit second, enter, and change that 9 to a 3. Hit enter, hit second entry. So now I put it into that equation, and I get out 9. All right, so be careful. It's real easy to make these little silly mistakes. I do it all the time. So ln of 3 plus 1, all divided by 2. On part B, let's copy this one down. So part B, I have ln of 4x minus 1 equals 8. And so typically students get stuck on this one because they forget what the log says. So basically, remember here, if you want, you can write it like this. Log base b of x equal to y says b to the y equals x. So b to the y equals x. And so on here, it's not written, but it's implied there's a little e here. So e to this is equal to that. And once you get there, you guys can solve this. So e to the 8 is equal to 4x minus 1, because that's what the log says by definition. That's what it is. And then I can solve this for x by adding 1 to both sides. So I add 1 to both sides and get e to the 8 plus 1 equals 4x. And then this implies if you divide both sides by 4, x is equal to e to the 8 plus 1, all divided by 4. And that should be my answer. Now let's check it, because again, it's easy to make a mistake. So left parenthesis, second, ln to get to the e to the, I'll put an 8 here, in parenthesis, plus 1, in parenthesis, divided by 4. So there's my x. And then I want to take ln of 4 times this number and take away 1. So ln of 4 times that answer and take away 1. And if I did it right, I should get back 8, which I did. Good, so these both check out to be right. So this is how we solve exponential and logarithmic equations. So very important to be comfortable with these two types of functions and working with them. Let's look at another example. So we're going to kind of go through what we did before. We talked about these domains and range domains. We're not going to do ranges in this section. But remember, there's really 3 things that limit our domain. So for our domain, we can't divide by 0, so we have to watch out for that. When we use square roots or even roots, we have to make sure underneath the radical sign this is greater than or equal to 0, and this is an even root. And then 3, when we're working with ln functions, we have to make sure whatever's inside there is greater than 0. If you look at the graph, you'll see that it's actually not defined. It's only defined between 0 and infinity. It's not defined for negative numbers. And it's not including 0. That's a parenthesis right there. So only good for positive numbers. So when I look at this problem, there's really two parts. I have a denominator. So I want to make sure e to the x minus 1 is not equal to 0. And that's one thing. That's from 1. And there are no roots, but there's another thing. So from 3, I want to make sure that this 2 minus x is greater than 0. And so for this one, I can solve this. E to the x, when is this equal to 1? I can ln both sides. So ln both sides. And then my x can come down in front. So I get x ln of e is equal to ln of 1. And so x ln of e is 1. So times 1. And ln of 1 is actually 0. And so I just get x equal to 0. So I do not want this to happen, because otherwise I'll be dividing by 0 in the denominator. And I also want 2 minus x to be bigger than 0. So if I add x to both sides, I get, so add x to both sides, I get 2 greater than x. Or I could flip this and write this as x less than 2. And so when I write my domain, draw my number line here, I want less than 2. So here's 2. And I want to take out 0. And I want it to be less than, so I'm going to go this way. And so my domain D is going to equal everything to the left, so minus infinity, up to 0. There's a hole at 0, so I don't want to include it. Union 0 to 2. And you don't want to include 2, otherwise you'd have ln of 0, which is undefined. You know, you can always test, if you try ln of 0, you know, it's going to say invalid, you know, error domain. You can go to the error. That's always good to do, and it's saying, I don't understand what you want me to do here, plugging in 0. And so this is my domain for this new function involving logarithmic functions and exponentials. All right, one last example for the day, and then we're going to wrap it up. So we want to find the formula for the inverse of the function. So the idea of this is you have this function y equals 4e to the x minus 3 plus 5. I'm telling you there's an inverse. So to find the inverse, the idea is flip out the x and the y. So let y be x and x be y. And then you simply solve this equation for y. So be careful with that 4 there. That's a 4. And so I'm going to subtract 5 from both sides. So I'm going to get x minus 5 is equal to 4e to the y minus 3. And then I'm going to divide both sides by 4. So I'm going to get x minus 5, whole thing, divided by 4. And I'm going to get e to the y minus 3. And now here's where I get kind of stuck a little bit, because I want to bring this down. And I remember, oh yeah, if I ln both sides, so ln both sides, I can bring this down in front. So this is going to be ln of x minus 5 divided by 4, in parentheses, is equal to y minus 3, so this quantity, times ln of e. And of course, the ln of e is what number? And hopefully you say 1. And then I'm going to add, I can drop that off. And so I'm going to add 3 to both sides and get my answer. So if you add 3 to both sides, you're going to get y equal to ln of x minus 5 divided by 4, and then plus 3. Now, if this is the correct answer, you can test your answer by plugging in a number. So over here, if you have x and y, and if you plug in 3 in for x, this is going to be e to the 0 then, and so that's going to be 4 plus 5, which is 9. So over here, if this is the inverse, which just means you flip x and y, it means if you plug in 9, you better get out 3. And so we can test this with our calculator if you want. So ln, I'm just going to plug it in right here. So I have 9 minus 5. And I'm going to need an extra parenthesis up here. So 9 minus 5, and then that's divided by 4, in parentheses for the ln, and then I'm going to add 3, and if I get out 3, I know I did it right, and so I must have done it right, because the idea is 3 goes to 9, And so if you go backwards, 9 better go to 3. In the next lecture, we'll talk about how we use these two functions for modeling things.